Welcome back, friends. This is Dr. Mlelwa Lecturers. Don't forget to click the subscribe button and to click the bell. Then put all for more updates. To join our Telegram group for discussions, just click show more in the description. Then if you scroll down, you see the links for the O-level and the A-level group. Welcome back, friends. This is Advanced Chemistry, and we are continuing with our topic of states of matter. The facilitator in this session, I am Dr. Mlelwa. In the previous session, we discussed about the concept of dissociation of gases when we was discussing about the abnormal results in the molar mass calculation of gases. So now in this session, we are continuing with the calculation of degree of dissociation and Vant Hoff's factor. So as we said in the previous session that degree of dissociation is the fraction of gas which has been dissociated. It is represented by alpha. So alpha can be calculated as number of gas molecules dissociated, then divided by number of gas molecules before dissociation or undissociated. So number of gas molecules dissociated divided by number of gas molecules undissociated, I will get the degree of dissociation. Now consider the example here. We have A, consider AX, then B, Y. This is the gas molecule. It dissociates to form, let's say, A, then C, plus B, capital B, then D, molecule. So where A plus B is equal to total number of molecules N. Total number of molecules after dissociation. Sasa tuangalie hiyo molecule. Mfano ni kwamba tuna A, X, B, Y ina dissociate kwenda kutengeneza A yule pale C plus B yule pale D. Then from there tunasema kwamba A plus B yule pale ni sawa total number of molecules N. Kwa hiyo hapa tunasema kwamba mwanzoni initially hapo tulikuwa na 1, hapo tulikuwa na 0 na pale na 0. So after dissociation 1, hii hapa imedissociate kwa kiwango fulani. This is represented as degree of dissociation alpha. Na hapa naangalia stoichiometric coefficient it will be A alpha, then here it will be B alpha. So hivyo ndivyo ambavyo tunaweza represent jinsi gani ambavyo dissociation inatokea. So this is the number of molecules before dissociation. This is the number of molecules after dissociation. So now, taking the number of molecules after dissociation, itakuwa ni sawa na 1 minus alpha plus A alpha plus B alpha. So this will be equal to 1 minus alpha, then equal plus. Hapo tunaweza kuweka A plus B, tukaweka alpha nje. Naona? Kwa hiyo tunasema kwamba but tulisema kwamba A plus B is equal to total number of molecules N. So itakuwa 1 minus alpha plus N alpha wale pale. Kwa hiyo ndio inaonekana kama vile ni total number of moles. Hii ukipeleka kule inaweza kuwa ni 1 plus N alpha minus alpha. So this is equal to 1 plus E hii hapa ukifactor out hapo inaweza kawa ni n minus 1, I mean n minus 1 then alpha. So total number of molecules after dissociation inakuwa ni 1 plus n minus 1 alpha. So tunachokuja kuangalia ni kwenye definition definition of degree of dissociation. Definition of degree of dissociation. Manake expected number of particles, expected number of particles ilikuwa niwe 1, lakini observed after dissociation, observed number of particles ni ngapi? Ni 1 plus n minus 1 degree of dissociation. So tenda kuona jinsi gani ambavyo tunaweza kuipata degree of dissociation. Tenda kuona. Lakini first now let's see about the Vant Hoff's factor, the concept of Vant Hoff's factor. What is Vant Hoff's factor? By definition, Vant Hoff's factor is the ratio of observed number of particles to the expected number of particles. That's the simple definition of Vant Hoff's factor. The ratio of observed to the expected number of particles. Now, let's come back to our question and to our derivation ambayo tulikuwa tumeiderive kule mwanzoni. Tukasema the expected number of particles itakiwa ngapi before dissociation? 1. But the observed number of particles after dissociation ngapi? Ni 1 plus n minus 1 alpha. So now Vant Hoff's factor represented by I can be calculated as observed number of particles divided by expected number of particles. So Vant Hoff's factor I is equal to observed number of particles in 1 plus, this is 1 plus n minus 1 degree of dissociation. Expected number of particles in ngapi? Ni 1. Now from this equation, let's call this equation 2 because kuna equation tayari tushai name kwa ni equation 1 inaonyesha relationship kati ya molar mass na number of particles. Tuite equation 2. From this equation now, tuangalie jinsi gani tunaweza kai make subject this what we call the degree of dissociation. Now, as we said that the Vant Hoff's factor is equal to 1 plus n minus 1 degree of dissociation divided by 1. I mean divided by 1. So hapo itakuwa Vant Hoff's factor is equal to 1 plus n minus 1 degree of dissociation. Now making the subject degree of dissociation, kwanza italeta kusema kwa Vant Hoff's factor minus 1 is equal to n minus 1 degree of dissociation. So degree of dissociation will be equal to Vant Hoff's factor minus 1 divided by n minus 1. So actually this is how we can calculate the degree of dissociation. This is how we can calculate the degree of dissociation. So hii ndio formula yetu ya calculate degree of dissociation. Degree of dissociation. Degree of dissociation. Kwa hiyo sasa I ni Vant Hoff factor, n ni total number of moles, na hiyo hapo ni degree of dissociation. Hiyo ni calculation ya degree of dissociation. Na pia jambo ambalo unatakiwa ujue ni kwamba kwenye association of gases, kwenye association formula haitakuwa kama ambavyo ilivyo hapa. Kwa hiyo kwenye association things are different. Kwa hiyo let I end up here in this formula, and in the next session I will go to look about the association of gases, how the degree of association can be calculated. This is the formula for degree of dissociation. Now in the next session we will be looking at the concept of association of gases and how the degree of association can be calculated. So thank you everybody. Don't forget to subscribe the channel and to share the video to your fellow students, and to like and to comment if you don't understand anything. Thank you.